Welcome student. Welcome. இப்போ நம்ம பார்க்க போறது application of integration in physics. Use of differentiation we have come across, and we will go on use of integration. Based on integration, we will have a sum. So first of all, before going to it, we just need of some basic things about differentiation and integration. When you say differentiation, displacement, differentiation, taking differentiation, after that we will have velocity. அப்போ டிஸ்பிளேஸ்மெண்ட்டை டிஃப்ரென்ஷியேஷன் பண்ணோம்னா வெலாசிட்டி கிடைக்கும், வெலாசிட்டியை டிஃப்ரென்ஷியேஷன் பண்ணோம்னா ஆக்சலரேஷன் கிடைக்கும். சரியா? இது வந்து டிஃப்ரென்ஷியேஷனில் பார்த்தோம். சரிங்களா? அப்போ டிஸ்பிளேஸ்மெண்ட் அப்படின்றப்போ எஸ் இஸ் த ஃபங்க்ஷன் ஆஃப் டைம் அப்படின்றது அந்த மாதிரி இருந்துச்சு. ஏன்னா டிஸ்பிளேஸ்மெண்ட் வந்து டைமை பொறுத்து கொடுத்துருந்தாங்கன்னா டிஸ்பிளேஸ்மெண்ட்டை டைமை பொறுத்து டிஃப்ரென்ஷியேட் பண்ண வெலாசிட்டி, வெலாசிட்டியை டைமை பொறுத்து டிஃப்ரென்ஷியேட் பண்ண ஆக்சலரேஷன். ஸோ we have come across displacement is differentiate with respect to time taken gives us velocity. Velocity is differentiate with respect to time taken. It will gives acceleration. Everything we know. Then what about integration? Integration is that simply acceleration to velocity, velocity to displacement. Acceleration to velocity, velocity to displacement. Clear? Velocity to displacement. Yes, actually it is a reverse process of differentiation. Okay, what is that actually? When we have some like s is equal to 2t cube plus 4t square plus 3t plus 1. Just differentiate with respect to t. When I differentiate with respect to t, ds by dt, so constant 2 of 3t square plus 4 of 2t plus 3 of t0, that is t1 minus 1 t0 plus 0. So now we have a differentiation form, that is displacement is differentiate with respect to time taken. So it is 2 of 6, 2 of 3, 2 3s are 6, 6t square plus 8t plus 3 of 1, 3 plus 0. So this is the form, this is the answer. After we will have what differentiation involved in here. Finally it is reduced to this form. T cube is reduced to t square. Just this whole term is taken into integration. Now it is made involved in integration. What will happen? We will go in now. Okay, 6t square plus 8t plus 3 within that bracket dt, integration with respect to t. So what will have? We have that is 6t, 6 t 2 plus 1 by 2 plus 1, then 8 t 1 plus 1 by 1 plus 1 close bracket plus 3 and what is that t plus c. So now we will have what is I is equal to 6 t cube by 3 plus 8 t square by 2 plus 3t plus c. This is the integral constant. Clear? When differentiation of 3t, so 3 into dx, 3 into dt, it gives 3t. Then finally we include integral constant. Clear? So why we are including integral constant? We have the reason. So I'll show you the reason why we putting integral constant. 6 3s are when 2 times, this is 1 times, 4 times, this is 1 time 3t plus c. So finally we have 2t cube plus 4t square plus 3t plus c. Just look at the differential form. 2t cube plus 4t square plus 3t plus 1. 2t cube plus 4t square plus 3t plus c. Here it is given as 1. Given as 1. Actually, this is given as 1 in 3t. Sorry, 3t. Actually, 3t plus 1. This integral constant, I don't know what when differentiation will gives us 0. This 1 is disappear. Now we got it back as a c, integral constant. So this is the reverse form. Okay, integral differential is a reversal form. Okay, we might understand about what the differentiation and the integration. So just we going into application of integral. Clear? Application of integral. Some sums we have, important sums. So we will go one by one. A particle is moving under constant acceleration. A equal to alpha t plus beta t square, where alpha and beta are constant. At t equal to 0 initial time, the position will be x0, v0. Find velocity as the function of time t. Clear? So here acceleration is given as a form of equation, quadratic equation. So a equal to alpha t plus beta t square. So clearly we can define a as a function of, as a differential form, dv by dt equal to alpha t plus beta t square. Then we can rewrite as dv equal to close bracket alpha t plus beta t square, close bracket, open bracket and close bracket, then dt. So it is now we can apply integration on both sides. dv equal to integration of alpha t plus beta d square plus into dt. Actually, here in sum, this is a integration with respect to time. So initial time is equal to t equal to 0, final time is equal to t. At initial time, the position will be x0. What not is not here as a position, actually here as a velocity v0. At t0, velocity, initial velocity v0 and final velocity v. Clear? It is given in the sum. At a starting time t equal to 0, at that instant of starting time there is a velocity, constant velocity v0. At instantaneous velocity, not at that time only constant. At instantaneous time there is a velocity v0. Clear? v0 to v. At the time taken t, the velocity reached v. Clear? This is we need to understand about the given one. So when differentiation dv is equal to v, upper limit minus lower limit, v here v0, then alpha t squared by 2, then beta t cube by 3, then t cube by 3. Clear? T cube by 3 close bracket, and this is whole bracket. What is that? T equal to 0 to t, upper limit minus lower limit. When after that we will have alpha by 2 t square plus here beta by 3 t cube So when upper limit minus lower limit, it t minus upper limit t squared minus 0 squared, 0 squared always 0. So there is no need to apply lower limit. So when applying upper limit minus lower limit, we will get this form, no problem. So here v minus v0 equal to alpha by 2 t square plus beta by 3 t cube. This is the formula, and the final velocity v equal to v0 plus alpha by 2 t square plus beta by 3 t cube. Clear? This is the velocity. So what about displacement? What about position? What about position? So we can write what about position in terms of time taken. What about displacement in terms of time? So this is displacement as a function of time. Okay, so we will move on it. So what we can define v velocity as a differential form dx by dt. So v can be written as a differential form dx by dt. Position changes with respect to time, displacement with respect to time, that is equal to v0 plus alpha by 2 t square plus beta by 3 t cube. Clear? Then what about displacement as a function of time? So we will arrive it. Okay, and actually when dx equal to v0 plus alpha by 2 t square plus beta by 3 t cube into dt, then taken both side differentiation, dx equal to of integration v0 plus alpha by 2 t square plus beta by 3 t cube of dt. Taking integration for individual terms inside the bracket, we will have the final answer. So before we go into integration, we should put limits at t equal to 0. The position will be x0. At t equal to t, time taken t, after time taken, the position will be x. Clear? So position will be x. So when integration taken for dx, we will have x, then applying upper limit minus lower limit, x minus x0. The final differentiation is done like that. Then what about this v0 into t, v0 into t dt integration for t0 to t. Then what about this and all the things? We will have a individual differentiation individual integration t0 to t alpha by 2 t square plus t0 to t beta by 3 t cube. Then we will have a final form when differentiation of this is v0 is a constant dt. So constant into dt, what is that? V into t upper limit minus lower limit 0 to t. Then alpha by 2 t cube by 3 upper limit minus lower limit, then beta by 3 t power 4 by 4 upper limit t, lower limit 0. After applying final form, we will have when applying upper limit minus lower limit, there is no need of lower limit because it is 0. There is nothing about when removing 0 from something. So vt as a form v0t, then alpha by 2 3s are 6 t cube, then beta by 12 t power 4, then integral constant c. So this is the final form. So x minus x0, this is the final form. X is equal to x0 plus v0t plus alpha by 6 t cube plus beta by 12 t power 4. So this is a position with respect to time. This is a position as a function of time. Clear? This is what we need to understand about the integration. So continuous class will be taken later. So there is part 1, 2, 3, 4 will be on. Okay. Thank you.